Hello, welcome back. You can see now I have two sleeping dogs. I think they're not staying awake for our fractions today, but hopefully you are. So we will continue on in our packet on page 9. We're going to look at some uses of mixed numbers and then just some calculations for mixed numbers and finish up the last couple of pages of this packet. Okay, so I'm going to close this and make this bigger. Let's start here. A recipe requires 3½ cups of milk. Bob put in 1¾ cups of milk and then ran out of milk. If he has to go to the store to purchase milk to finish the recipe, how much more milk does he need? Okay, so again, we're really working with small numbers, just basic numbers. The idea here is to get the concept. And then, when we get the more complicated numbers, we can certainly use a calculator or just work it out by hand. But I just want you to see that, the idea here. Okay, so this is going to be, he has 3½ and he already used 1¾ cups. So he just needs whatever's left. Think about that. That's going to be a subtraction problem. 3½ minus 1¾ And then when I subtract that, that's going to tell me how much more milk he needs to finish out the recipe. But I am going to need to get a common denominator here between 3½ and 1¾ So look at the fractional components there. If I get a common denominator of 4, that might be somewhat helpful. Let's see if I can do that and keep it as mixed numbers. So I'm going to keep this as 3, and I'm going to change this to 2/4. This already has the denominator 4, so that doesn't need to change. But I run into trouble here, because if I just want to subtract the fractions, they do have equal size parts. They're both fourths, but this is 2 and this is 3, so that's a problem. So sometimes when this happens, you might want to go ahead and just change them to mixed numbers and then subtract it that way. Change it from a mixed number to an improper fraction and then subtract it that way. So 3 times 4 is 12, plus 2 is 14 over 4. 1 times 4 is 4, plus 3 is 7 over 4. And now you can see that this is just going to be 14 minus 7, 7/4. And if you want to change it back to a mixed number, you certainly could do that. 4 goes into 7 one time with 3 left over. So that's 1 3/4. This is in cups. How much more milk does he need? He needs 1 3/4 cups. So sometimes it's easier to actually just change it to an improper fraction, do the calculation, and then change it back if you need to. On the next couple of slides, or at least this one, you're going to see some more problems to look at. Subtract. So try that one. It's the same idea. You have a common denominator here of 7, but you can't take 6 from 2. So it might be easier here to go ahead and make these improper fractions. I know there are multiple ways to do it. You could take the 17 and make it a 16 and add 7 here, but sometimes, as we work toward algebra, it's just easier usually to do this. Now that one has larger numbers than the last one did. But don't worry too much about that. It's just 17 times 7. Okay, that's 119. Plus 2 is 121 over 7. Minus 5 times 7 is 35. Plus 6 is 41 over 7. So that's about as large as they're going to get. So 121 over 7 minus 41 over 7, and that would be 80 over 7. Then you can change it back to a mixed number. Okay, how many times does 7 go into 80? 80 divided by 7 is 11, right? That would be 77. 7 goes into 80 11 times. It would be 77 with 3 left over. So 11 3/7. would be your answer. Now down here, if you want to add, this is just showing you how to add. Some things are fractions, some are mixed numbers. They have different denominators. But one thing you might want to do is start to look for things that you could group together. This is all addition, even though these two are within the same set of parentheses. There's nothing else happening other than addition here. So the parentheses aren't really needed for anything at this point. So you could go ahead and put things that were common together if you wanted to, and add the ninths together first. Or you could go ahead and get a common denominator for everything. There's a couple of ways you could do this one. But I'm just noticing that these two have a 9 already. And there's no particular reason why I need to work what's in parentheses first, since this is just one addition. There's not anything else going on. Now, if it were a bigger problem, I couldn't do this. We'd have to look and see what else is going on. But let's just add these two because we haven't done one like this. 4 ninths plus 5 and 5 ninths, they already have the ninths. So you would keep your whole number and add the fractions. 4 plus 5 is 9 over 9. Don't change the denominator. Okay, so what's 9 over 9? Isn't that just 1? Anything over itself is 1. So that's really 6. And then I have this 3/5 here. So it's really 6 plus 3/5, which is just 6 and 3/5. Okay, so that's, you could do it making everything over 45 if you wanted to get a common denominator, but sometimes you just sort of have to look at the problem and see what's going to be the easiest way to work it. Okay, so let's go on and look at that next one. Multiplication of fractions. Okay, multiplication of fractions is generally easier than addition because all you do is top times top, bottom times bottom. So just multiply straight across. 2 times 3 is 6, 5 times 7 is 35, and then reduce it if you can. Okay, if the top's up here and the bottom's, if none of these will reduce with each other, anything on top can reduce with anything on bottom. If that won't happen here, it won't happen here either. Okay, so you just multiply top times top, bottom times bottom. You do not need a common denominator to multiply fractions. This one just is a review of multiplicative inverse. It's just saying that if I have a number, let's say 5 instead of a, and I multiply it by 1 over that same number, then that's going to be 1. 1 times 1/5 is 1. 2 times 1/2 is 1. 10 times 1/10 is 1. That's that property, and that's just called a multiplicative inverse. When I multiply a number times 1 over that same number, they basically always multiply to 1. And then sometimes, though, similar idea, any non-zero rational number has a unique rational number that's called its reciprocal. And a reciprocal is just where we flip the fraction over. So for example, if I have 2/3, then its reciprocal is just flip that over, 3 over 2. And the property says if I multiply a number and its reciprocal, it's going to cancel out to 1 every time. Why does that happen? Top times top would be 6. Bottom times bottom is 6. Any number over itself is 1. Okay, so a reciprocal, if I have, I don't know, let's see, 7 over 5, its reciprocal is 5 over 7. Just flip it over. And if I multiply 7 over 5 times 5 over 7, that's 1. That's 35 over 35, which is 1. So just kind of remembering that vocabulary is good. We use the idea of a reciprocal or a multiplicative inverse or both when we're doing division of fractions. Okay, because what we do here is when we divide fractions, we have a fraction divided by another fraction. what we can do is, instead of doing the division, we can change division to multiplication and multiply by the reciprocal of that second fraction. So you may have heard keep, change, flip. Okay, so you keep the first fraction like it is, change division to multiplication, flip the second one over. We'll do a couple of those on this other page here. Okay, so looking at this last page of the notes, let's just try some of these. This is just sort of some mixed problems. Again, without a calculator. So 2 1/4 times 12. Okay, several ways you could do that. See what you can do with that. I mean, there's not a right way that's necessarily best. It just depends on the problem. As long as you come out with the correct solution, you're okay there. You could, some people would want to split it up and multiply 12 times 2 and then multiply 12 times 1/4 because that's something you might could do in your head, and that would work. But some people might want to say, all right, I'm going to change this. 2 times 4 is 8 plus 1 is 9/4 times 12 and do it that way. How do I make 12 look like a fraction? Stick a 1 underneath it. Okay, so you can do a lot of different things. You could change the 2 1/4 to an improper fraction and then multiply it by 12 over 1. And anything in the top line when you're multiplying can reduce with anything in the bottom line. Doesn't have to be right over top of itself. So like, for example, 4 goes into 12 3 times. Right? So now go top times top. That's 27 over 1, which is 27. I would have gotten the same thing if I had said 2 times 12 is 24. And then 1/4 times 12 would be 3. And add 24 to 3 gives me 27. So like I said, there's more than one way to work it. 6 times 3 1/4, similar. 6 times, if you want to go 3 times 4 is 12. Plus 1 is 13 over 4. Okay, if it helps, write the 6 over 1 so it looks like a fraction. Doesn't change the value of it. Now, 4 doesn't go into 6 exactly, but you could reduce them. 2 goes into 4 2 times, and 2 goes into 6 3 times. So you could reduce them a little bit. And then go top times top. 3 times 13 is 39. 1 times 2 is 2. So it's 39 over 2, which, you know, you can, 2 goes into 39, 19 times? With 1 left over, 19 and a half. You could write it as a mixed number. Okay. Let's do a couple of division ones. Find 4 1/2 divided by 2. 4 1/2 divided by 2. Okay, now you need to remember that when we're dividing, it's really, you can do multiplication with the reciprocal if you want to. Now this one, you know, you might could do in your head with these numbers. That's no problem, okay? Divide remember this is really 4 plus 1/2, and we're dividing it into 2 equal pieces. So half of 4 is 2, half of a half is 1/4, so the answer is going to be 2 1/4. Okay, so there's more than one way to get that though. You could change this to 2 times 4 is 8 plus 1 is 9 over 2. And instead of saying divide, you could change the multiply and change the 2 to its reciprocal, 1 over 2. And then again, you can see this is 9 times 1 is 9 over 2 times 2 is 4, 9/4. Still 2 1/4. Okay, so there's more than one way to do these things, but that will work. 3/4 divided by 4. This is probably just as easy to go ahead and work it out by using multiplication with the reciprocal. So when we divide with fractions, we keep the first fraction like it is, or the first whole number, whatever's in front of the division sign, like it is. Change divide to multiply, and then take the reciprocal of the second. Okay, so instead of 4, we would have 1 over 4. Same thing. top times top, bottom times bottom. So 3 times 1 is 3, 4 times 4 is 16. So 3/16. Okay. Here's an application. Mr. Wagner makes wooden coasters for glasses. He cuts small pieces of wood into 1/2-inch thick slices. How many slices can he get from a 5-inch piece of wood? Okay, so really what he's doing is he's taking a 5-inch piece of wood and he's cutting it into 1/2-inch long pieces. So this is really, my hole is 5 and I'm dividing it into 1/2-inch long pieces. Now this is one of the most commonly missed problems because people will say, oh, it's 2.5. 5 divided by 2 is 2.5. Well, that's a fact, yes, but that's 5 divided by 2. The question is, what is 5 divided by 1/2? Not 5 divided by 2. Okay, so if you want to change this, okay, this would be, when we do division, change to multiplication and then flip this over. So 5 divided 1/2 is the same as 5 times 2, not 5 divided by 2. It's 10. The answer is 10. Okay, so see if you got 10. If you're not sure about it, draw it. Sometimes that helps. This is a 5-inch piece of wood. So let's see. 1, 2, 3, 4. Try to eyeball it here. So 1 inch, 2 inch, 3 inch, 4 inch, 5 inches. Now I need 1/2-inch pieces, so I'm going to have to cut each one of those in half again. He's making coasters out of this 5-inch piece of wood. How many coasters can he get? How many slices? 10. Okay, not 2.5. So be careful there. When you divide something by 1/2, it's the same as multiplying it by 2. And this last slide is just sort of estimating. So estimate the following: 3 9/10. Okay, how are you going to estimate that? If you were trying to do that and you were just out and about and you needed to figure out 3 9/10, that's kind of maybe not as easy to calculate in your head. So I'm going to say that is about, what? About 3 or about 4? Well, 9 out of 10 is almost 10 out of 10. So this is very close to 4. I would estimate that at 4. And 5 1/7. You know, think about that. Is that 5 or is that 6? 1/7 is very small. So I'm going to say that's a lot closer to 5. So if I were estimating that, I would say that's that's about 20. 4 times 5. Same thing here. 6 1/3 is a lot closer to 6 than it is to 7. Divided by 1 7/8 is a lot closer to 2 than it is to 1. So that's about 3. That's just estimating. So that's what's there. Now, let's look at a couple of the worksheets that you have. If you don't have the worksheets yet, and you really didn't need them yet, you might want to just pause this until you get your worksheets. So we will look at, let's see, this one first. How do you get 27 kids to carve a statue? Okay, so let's look at that first. I'm just going to show you basically one off of each page. I don't think you'll have any trouble with these, but I just want to make sure you understand the directions. And then again, these are going to be sort of self-checking because of the answer. Okay, so let's just pick one here. How about this circle? Write the fraction for the part that's shaded. Let's just do this one right here. Okay. For the part that's shaded, well, this is just trying to get you to understand that when you do a fraction, what does it mean? It means this circle has 3 equal pieces. 2 of those 3 are shaded. So the part that is shaded is 2 out of 3. Again, a fraction is showing me how many equal pieces there are, and the numerator shows me how many of those I'm taking, or in this case that I'm shading. So E is 2/3. So you're going to come down here to the bottom and find 2/3 and put an E in that slot. Okay. And there may be more than one sometimes. So if that happens, then just, fill that in more than once. Okay. Let's look at the one that's on the back of that one. This has several puzzles at the top, but what you're supposed to do is compare the fractions or the mixed numbers by writing a greater than or a less than in each of the circles. Okay, then it says circle the letter above the larger number. Write this letter in the exercise each time it appears in the code. Okay, so let's just look at number 1 here. 2/3 and 3/5. We have to compare those. So in the notes it talks about how you can compare these fractions. If you want to go ahead and get a common denominator of 15 for both of those and compare the numerators, that's fine. But if you recall, we also did a cross product. 2 times 5 is 10, and that stays on this side, on the left-hand side. So start on the left. 2 times 5 is 10, and then 3 times 3 is 9. That's what goes on the right. Okay, 10 is bigger than 9. So that means 2/3 is bigger than 3/5. And it says to circle the larger number, or circle the letter above the larger number. So in this case, that's Y is the larger. 2/3 is larger. And then you're going to go up to the top each time that appears. So it says, write this letter above the exercise number each time it appears in the code. Okay, so let's see. Circle the letter above the larger number. We did that. Write this letter above the exercise number each time it appears in the code. So it looks like that would be a 1 is a Y there. Okay. Okay. Let me make sure I've got those directions right. So, okay. All right, so then let's just try another one. Let's do the one below it. Okay, 1/3 and 2/9. So 1 times 9 is 9. 3 times 2 is 6. 9 is larger than 6. So 1/3 is larger than 2/9. Circle the letter that is above the larger one, E. So every time I see 4, I guess, I'm going to put an E. Okay. I don't see any other 4s. Oh, there's a 4. Okay. All right, so that's how that's going to go. Now let's look at the other worksheet. We have, what did the boy snake say to the girl snake? This is just representing fractions graphically on a number line. So you're going to write the fraction for the length of the bar above each number line and find your answer at the bottom of the page. Okay, well this one is 0 to 1. Notice that on your number line. And so look to see how many, how is this divided? I see 1, 2, 3 tick marks, but that doesn't mean it's divided into thirds. Look how many spaces there are. 1, 2, 3, 4. So if there's 3 tick marks, it's divided into fourths. And how many are shaded? 1, 2, 3. So the shaded part is 3 parts out of 4 total parts. 3 parts out of 4 total parts. Whereas the one below it, 1, 2, 3, is 1 part out of 3 parts. So 3 parts out of 4. So U is 3/4. So you would just find that at the bottom. Put a U. And then A is 1/3. So find that at the bottom and put an A. Okay. All right. And then lastly, how do you turn a banana into a vegetable? Okay, so now you're going to divide up the number line as indicated and then locate the given numbers. Okay, so for example, let's do that second one down. It says thirds. So you're going to divide your number line up into thirds. Okay, here's 0, 1. So I need to make 2 tick marks. Okay, this is 1/3, 2/3. Right. Similarly, I just keep going. 1 would be 3/3. Okay, so this is 4/3, 5/3. 2 is 6/3. 7/3, 8/3. 3 is 9/3. Okay, so divide the whole thing up into thirds like that. And then it says to put them on there. So T is 2/3. So here's T. U is 4/3. Here's U. N is 8/3. I is 1/3. D is 9/3. Okay, P is 5/3. And then A is 2 1/3. So here's 2 1/3. That's the same as 7/3. You can start to see then it's making words, right? It, up, and so the whole thing is going to make a phrase when you put them all together. But that's what they want you to do there. So I don't think that's going to take a very long time. And also, then I want you to go to your CEI workbook. Let me get mine out here. Your CEI workbook. And then now you'll have some fractions to do here. So in the CEI workbook, you're going to do page 11. So this is page 11, 12 and 13. Okay, so 11, 12, and 13 in that book. So I'll write that down. Pages CEI workbook, page 11 to 13. Okay. And that should, we've already done 14 and 15 with the decimal operations. Okay. And the other page that we need to do is skip over and do page 22. So 11 to 13 and then 22. So this is just comparing, again, using less than or greater than. You're comparing some mixed numbers, some fractions, some decimals to each other, just to see what you can do. And again, try to do that without the use of your calculator. And of course, everything in this packet has answers that you can check. Okay, so you should be able to check everything. So let's start with that. And then what we'll do is on Wednesday, we'll hopefully look at some of my math lab things. And then the other information that we'll look at maybe this week, I don't know if we'll have a chance to get to it, is just converting fractions, decimals, and percent. That'll be our next thing. And then we'll head to integers after that. So hopefully you can work on these fractions. And if you have any questions, please be sure to go ahead and send those so that we can look at those. Thank you, and I'll look forward to seeing you Wednesday.